the flow of unlocking skills, we have already done animation. We are already working on product designing. That's a 4-day workshop. And today we are on a slightly different topic. That is 3D digital game art. And we have with us Mr. Bhaskar Nagendra. Mr. Nagendra is IndiaSkills jury member and faculty of 3D game art. You know, I have a lot to tell about him. He is a faculty of 3D game art in Asian Institute of Design with over 12 years of experience in top animation studios and being excellent in academics. With master's degree in visual communication, he has worked for various studios in modeling and rigging projects and have been a part of developing course, curriculum, and examination cell for animation colleges as well. So he has been a jury member of 3D game art in IndiaSkills 2019. So with this, because I even don't know. Mr. Nagendra, you're most welcome on the Vidyadaan platform. Somehow we are facing a little problem with your video. Yes, you are here. Yes, so you are muted.
Yes, yeah. Yes. There was some technical issue. I couldn't switch on the video. Yeah.
Yeah, gaming have been a part of everyone's life since childhood, right? We keep on playing game. Abhi to we have Ludo King also, and we are crushing the candies, and we have PUBG. We have like I think I'll not even be able to name 1% of what all games we have. So, how important is rigging in that game, game designing and animation?
That's what the whole the webinar is all about today. So it's more of informative and little bit of the practical thing that what we are going to do today. So it'll make you understand about overall how rigging works, right, for this games. Yeah.
I will also note down my questions, and guys, you can also send in your questions in the Q&A section, and we will get all the answers at the end of the session. And here I would love to give you the rights so you can show us the presentation and we can continue with the session.
Yes. Yeah. So thanks, Pooja. Thanks for the introduction. Let me start my presentation. Good morning, all. Yeah. Yeah, so we'll answer all these things. Like already there are some questions coming in. What software is used for rigging? There are a lot many, but today, yeah, I'll be using Maya for that. But yeah.
Trust me, you will have a lot of questions, and at the end of the session, you would not be able to answer them all. So guys, I still request that you send in the questions in Q&A section and not in the chat section. Chat is only for our communication. You can send in your comments, you can give us the feedback, and yes, you can click photos with Mr. Bhaskar Nagendra and you can put them on social media, tagging Media and Entertainment Skills Council and Vidyadaan. And yeah, let's continue.
Okay, thanks. Yeah. So let us jump into the presentation. So yeah, a straightforward first question that I want to ask you guys, like how many of you are already into rigging? Since we are talking about rigging today, so how many of you are already into rigging? Okay.
We can see hands raising.
Yes. Yeah. Let me share my screen too. Right. I think you can see my screen, right?
Yes, now it's visible.
Yes. Yeah. So yeah. So I think there are people who knows like who are into rigging and who are doing this before. So that's what I can see from here. And some of okay. So coming back to this. So in this session, like the overall session for this for 1 hour to 45 minutes to 1 hour. So I will be explaining you what is rigging. So in general about, because rigging is there in animation also, rigging is there in games also. So I'll be explaining you what is rigging in general. So before that, I'll be explaining about how a 3D pipeline works, like how will be 3D pipeline would be. and then where rigging comes into it, and what is rigging and how we generally go about with the rigging, right? So that's what I'll be explaining in this whole thing. um, so if you see the like in the end of this session, what you are going to get, that's what I just explained, that you'll understand how rigging works, and differences and similarities between film rigging and game rigging. There are differences, a little bit of differences on the technical aspects of it. That's what I'll be explaining, what are the main differences that will be there, right? So we'll start with the 3D pipeline for a movie making or maybe a game industry. So this is on a broader uh, s- like view I'm showing you here. This is not like in depth each and everything. That's what I'm not going to explain about the overall pipeline, but what are the different stages. So that's what I'll be showing now. Let me just keep it here. Yeah. uh, okay. So all the answers and all, like all of the questions you are giving now, I think you, because already you guys are posting into the chat, please post it into Q&A so that I'll answer in the end of the session. Yeah. So the 3D pipeline, the overall 3D pipeline, what we have. So on a broader way, so it looks like this. So an idea that starts with an idea, either when you're doing a character design or anything. So this particular thing, what I'm showing you here is about one particular prop or maybe one particular character that we are going to use inside a game. So it generally starts with an idea, and the idea will shift to modeling. That's a 3D modeling, because we are dealing with the 3D game. So creating the 3D model for that, and then surfacing is about giving that materials, textures, all those things comes under surfacing. And then comes the rigging part. So this is our topic today, the rigging. And after rigging, it goes to animation, and then it goes to render or engine. So this is where the difference is. The main or the basic difference comes here. The, like the end product wise. So these are the two differences that we generally see. So yeah, one is for the film, we generally render it out. Like whatever you create, we just render it out, and then um, make a video or anything, or an image or video, whatever you want. So that's what we are going to do in the render for a film. But if you're going to the games, so this is what makes the difference. So we'll be using something called as a game engine. Yeah, some are answering like Unreal Game or game engine or whatever. There are so many game engines out there, like we can use any of those. I'm not specifying one particular thing, or I'm not pointing out on one, but there are so many that we can use for that. Either Unreal or Unity, CryEngine. There are so many. The difference here is, so engine is more like a real time, and it's totally a different environment from what we created in the actual 3D software like Maya, Max, or Blender, for the matter, anything you create. So this engine is something like, again, it takes all the data and then computes it back to a game, right? So who are already know about game engines, yes, so you already know that how it is. But this is the main difference. Apart from these two differences that we generally see, there are even some more differences modeling wise, surfacing wise, or even rigging and animation wise also there are. But what we are concentrating today is more about rigging, how rigging is important, why we have to do rigging, and what are the different things. That's what we are going to do, right? So quickly going to the next slide. So yeah, so this is just the pipeline differences. Main differences is about the end product. One is a film render, and the games will have export to game engine. So yeah, so coming to the actual topic, rigging, the question, what is rigging? So if you guys know, you can use now the chat and then answer me like, what is rigging according to you? Some of you are already into rigging, so I want to know from you guys, like, what do you understand about rigging? Yeah. Any guess? Any answers? Adding skeleton to your character? Anything else? Anything else? Ring is basically adding bones to character. Digital skeleton, motionary character, adding bones. Okay. So there are answers coming in. So I see here most of you are saying like rigging is about creating joints, creating skeleton or creating joints, and then connecting it to the mesh, right? So that's the basic answer. Generally, we understand about rigging, but to look into a different perspective, what rigging is all about, I'll show you two images, which is totally different from this. Uh, do you know these two things? You saw these two things before? Uh, yeah. So one is a ship or a pirate ship or that ship thing. The other one is the puppets. Yeah, we see those two here. So what are these two? Like, even actually these two are called as rigs. Like if you see the boat thing, that wires and all, whatever we are seeing there, even those are called as rigs. And if you see the other thing, the characters, what you see, the puppets, even that's a kind of rig what we there. So in both the cases, what we are doing here is not creating bones or anything as such, right? Because that is the core thing that we need to understand. When we are rigging something, rigging doesn't mean just creating joints. I'm talking about in general, not just about games, in general, the movie or anything, because if you're doing in the movies or something, if you have to rig maybe a very small prop, which is not even a character, it's just a very small prop, maybe a pen drive or something, you don't need any joints there, right? So even without joints, you can actually create controls for that, which can be used for animating it, which can be used for moving it, do all kinds of animation on top of it. So we are not creating any joints there. So the general thing which we always say, like rigging is joints, no, it's not just about creating joints. It's about creating controls for a character. Like if you see in this case, the wires and all on the ship, right? Like, so in this case, the wires on the ship and all, so those are something like we cannot climb there and pull those cloths down. So we put this ropes, and when you pull these ropes, the cloths will come down, or you can pull it up. Same with these puppets also. So these strings, whatever are there, these white strings, so moving those strings, we actually create motion to the character. So rigger's job is actually creating those controls for the characters, right? So it's not just creating joints. There is even more into that. That's what I'll be showing. I'll make you understand how it is. So, just like about what is rigging, it's like creating controls. And yeah, this is one more thing. Like just before the session, Pooja is asking like, um, what is rigging? That's where I was telling, like, see, if you see modeling or if you see animation or anything, in the end product we generally see that. But when we see riggers, we don't see them on screen, because they are the technical support which will be there in the background, which we are like helpers for animators. So animators comes to us and asks for, like, I need this control, I want the control to be like this, so that I can animate the character, I can move the character like this, I want this kind of flexibility in the character. So as a rigger, so our work is to create those controls to make the work of the animator easy and faster. So in the end, it's all about creating a foolproof rig, so which we can give it to animator. So it's like fully logged rig, and it is like more of a creative job animators will do than more of technical. Because if we give the technical thing also to the animators, it might hinder the final output, because they have to work on both the things, like traveling in two boats. So as a rigger, we need to make things as simple as possible for the animator to work with, right? So, and yeah, rigging is mostly a technical department. Like, yeah, if you see who can become a rigger, like whether somebody asks, can I become a rigging artist, how to become a rigging artist? So everyone, anybody who is interested in doing this, yes, you can become a rigger. um, it's more about logical thinking that you need when you're doing rigging. Something like, um, if there are two objects and you want to, like, if you want to move an object from one place to other, how you want to rig it, it's the logic that goes behind it that explains you how you want to connect those two objects, right? So that's what you need to have. And programming, not that compulsory, but definitely important in the later points of stages, when you start creating your own scripts, or maybe you want to create procedural rigs or something. That's where definitely programming is also important for you. Yeah. So if we break up the overall process, because rigging department can be divided into two things. One is uh, the rigging department, and then the skinning department. So this overall comes under something called as a character TD. So wherein they'll be doing this, creating rig for that, and then creating deformations of skin for that, right? So that's two stages. One is the control setup, and the other one is skinning a deformation. And you can say I'm not exactly mentioning this as joints or something, because that comes under control setup. They're not the actual things. But there is a but even for this, because I will be explaining what differences it is, right? Then you'll understand. So if you're doing a rigging pipeline, it's generally for a character or something, where if you're doing, I'm starting with joints. Joints goes to connections. So connections are the main things about rigging. So that's why I highlighted this. And then creating controls, and then taking it to the animation that comes next. Similarly for skinning also, like once the rigging is done, we do something called as binding. That is connecting the rig to the character, and then looking into the deformations, and then final cleanup, right? So these two things comes in side by side. And if you see all these pipelines what I mentioned here, they look like as if there is a very nice, clean, linear flow. Like if you go back to this, sorry, just coming back, it looks like a very one way process of starting with an idea and then going straight like this. Looks like a very clean and neat process, but not actually. Technically this is the process that we follow, but at some point of time there will be situations wherein you need to come back, do something else, and again go back like you do. That's where as a modeler also you need to know how rigging works, wherein once it goes to rigging, if you see the deformations are not correct, and it is the problem with the modeling, like there are no proper loops added or something, then again we need to send it back to the modeling department, who will be correcting this, and then again coming back. There is a lot of to and fro that happens inside this sometimes. In any kind of studio, it's not that it's not properly maintained or something, but it happens. Definitely there will be some kind of technical issues or something happens, so there will be a loop which will be happening always in between. That's where the final product looks good, right? So to this skinning, yeah. So the main differences, like coming to the differences between film and the games. What is the main difference? In film, when we are rigging something for a film, in that we have like freedom. We have freedom for doing anything, because we start in the same software, we render in this, we give the final output in the same software, and there is no much of technical difference that will be happening. So it's like a single flow that will be starting and then ending till the final product is done. So we have that freedom of creating anything we want, or doing whatever we want. And we can create as like how much ever complex rigs we want, maybe kind of dynamic rigs. Like there are so many kinds of things that you can do. There is no limitation as such when we are actually working with a film character rigs, right? It can be as complex as possible. But coming to the games, there are limitations when you're creating something for the games. There are limitations wherein, depending on where you are going to put it, what kind of engine and the final product, whether it is a mobile game or maybe PC or console, whatever kind of game you're going to create, based on that, there is a limitation of the number of joints you're using, or kind of deformation that you're using, or maybe changing the animation from one to other, sharing the one animation or one kind of animation and putting it to other, rig from one to other. So all these things are there in games, right? But in film you can have multiple rigs which can be used like multiple times, because in that there is nothing like real time that happens in the end. So everything will be straight ahead, and we'll be seeing everything directly there itself. So coming to film rigging, generally, like what are the positives that we see in film rigging? Just now what I explained, there are no limitations. We can, yeah, this is one more thing, like we can create our own, we can use our own custom scripts. Like we can create our own scripts, or maybe you can take some scripts like third party plugins or whatever, and you can use on the rigs without any issue, because it's the same software or same pipeline that we are going to use from the starting to the end. But if you're going to take this character rigs from your 3D softwares like the Maya or Max or anything, and then shifting it to a game engine, there definitely will be limitations when you're using scripts, because some scripts will create some special nodes for the rigs, which are not 100% supported by game engines. That's where we have a limitation, and our rigs to be as should be as simple. Like we need to create simple as possible, right? Cons, not much, nothing to mention much, because it's like freedom is like too much for us in this. Coming to the game rigging, it's easy to build, but the other things like the problems with game rigging, then negatives or the cons, what we see is the engine restrictions. Depending on which engine you're going to put it, based on all those things, you need to look for a different workflow. And the bone count, and the deformation restrictions, and the script restrictions, that's what I just explained now. So these are the main differences between a film and then the game rig that generally we see, right? So if we, yeah, this is again one more important thing, like whatever I am telling right now, whatever pros and cons I'm telling right now, they were even worst when we were actually creating games in the for the little older generation, because that time the game engines are not that powerful. And if you see this, like if you see the kind of evolution that you see in the games, like it was something like this before, the same character, and now it's much more complex. And which is possible because our game engines right now, what we are using, will support this. The kind of hardware we are using supports this. And from the uh, like previous stages, like when the rigs were done before, there were situations wherein maybe there are blend shapes that doesn't work much, maybe smooth skin doesn't work much, but we have the liberty now with the technical advancement. We, like whatever we are seeing inside a 3D package like Maya or Max, we can straight away use the same kind of setup even in the game engine. So that much evolution is there now. So I'll just show a small video. Like this is a new video which is released by Unreal 5. I think most of you saw this. All right, most of you know this. This is not related to rigging or something else. It's just the overall that new game engine that we know. So I'm not going to play the whole video. I'll just play a small part of it. Let me, yes. So yeah, if you see that uh, if you see that, yeah, if you see that video of this, the Unreal Engine 5, the new version, which is not released yet, but you can see the kind of the quality change that was there from the previous versions to what we have right now in this version. So there is definitely a technical advancement. Like this particular thing, what we are seeing is like the high poly models that we generally see in ZBrush are directly used here. Directly, like it's like literally directly used here, right? So something like this, something like technical advancement, something like this is happening. Same with the rigging also. Like previously it was just joints or maybe rigid deformations, but it came to something like smooth deformations, blend shapes. There are even more kind of complex deformations that are possible inside the engine also. And there are even rigging tools inside the engine. Some of the engines has their own rigging tools too, right? So yeah, seeing the types of rigging that generally we see, uh, can be either film or anything. Generally what we see is like a procedural rigging. So this is where we use most of the time like uh, script or maybe a mathematical formulas or something that we generally use to make um, mathematical formula, something to create a rig, automated kind of thing. That's kind of a procedural. Something like in simple terms, if I have to explain, we use something like a sine function or maybe cos function, sine or noise function in Maya. If you're using Maya, so we can use it as simple as those things, or maybe nodes for creating a rig. So that comes under procedural rigging. Next is joint based rigging, which is in general we always use creating joints and then rigging something. Dynamic rig, again we can use joints, and without joints you can do this, but the final product that we see is a dynamic, wherein it's like a secondary animation that happens follow through, or secondary, wherein if you move the character, maybe a tail or maybe a ponytail or whatever, so all those things will be animated like dynamically. So that can be done using a dynamic rig, using dynamic options. But again, all these dynamic rigs or all these things whatever we create straight ahead, you cannot export it to games, right? That's where we do a workaround for all those. And then deformer based rigging is something like maybe you have maybe a ball rig, and the only thing that you want in that ball rig is maybe moving, squashing and stretching, or just moving. So in that case you don't need a joint or anything, you can just straight away create some kind of deformer, a squash and stretch deformer, and then start rigging it, right? So seeing all these things, like if explaining all these things and making you understand, definitely it might look like it's a very lengthy, it's a very difficult process. How many of you feel rigging is a difficult process? Any answers? How many of you think, like, because most of us coming into this field are more into artistic, and rigging is technical, so people might think, yeah, rigging is difficult. uh, I think it's easy. Yeah. Me too. Me too. I guess skinning feels more difficult. Yeah, yeah. So definitely, the first time when somebody comes into this and sees rigging, and seeing all these options, whatever I'm explaining right now, definitely people think it is complex. It looks complex, but it's not that complex. If you understand the logic behind rigging, and if you understand how rigging works, the overall process of rigging is actually very simple. It's not that complex at all. If I have to break the overall rigging process, not the rigging process, creating controls inside Maya, like I'll be using Maya for this. So I generally see that into only these many things. Like if you understand these tools inside the software, Maya or Max has different names for all these things, right? Seeing all this, like if you know only these things, you can be a rigger. I mean, technically. On top of it, uh, you should have better understanding about how the deformation should be. All those things come secondary. But for creating controls, if you know these things, how many of you know these things? Whoever is beginners into this, I don't think so. I'm expecting you will be knowing this. But if you are already into rigging, I think most of you know this inside Maya. Yeah, so you definitely know all these things, how we generally do. And if you know these tools, that's enough to create a kind of rig. All right. So parenting and grouping, uh, all these things whatever we are seeing here are for connecting objects. You agree, right? So you have a parent and then you have a child, and when the parent moves, the child should move with that. Something like the puppet, what we saw, the puppet characters that we saw with the strings. So in that, the strings are the parent and the character is the child. So when you move the strings, the character will move, the puppet will move. Okay. So that's how it generally works. That's how it generally works. Like we'll have a control and connecting the parent to the child. And in the parenting or a grouping or anything that we do, we generally take two objects. One will be the parent and the other will be the child. And when we move the parent, child will automatically move with that. And each one, like I always keep them in an order like this. So I always start with parenting. Like if I have a control and then a child, like a parent and then a child, I always start from the beginning of this, wherein I see whether I can finish this thing using parenting or not. If I cannot do it with parenting, then I'll go to the next thing. Or if that is not the case, I'll go to the connectionators, then set driven keys and scripting. It depends. Again, it depends on character to character. It depends on the object to object, and what you want the final product to be. Because some of these things, if you try to use, they might not export exactly how you want to the game engine. So in that case, there is a workaround wherein you create the rig, a high quality rig, and then you will be creating a rig for the game engine, and then we'll be transferring this animation from that to this. So there are plugins for doing even those kind of stuff, right? But I always go from this order, starting with the parenting. If it is not working out for me, generally parenting, I don't, that will be the least option that I generally use. If not parenting, I always start with the constraints, right? And each has its own importance. Like when you see parenting or constraints or connectionator, each has its own importance. Just to tell you what it is, parenting is like a straightforward connection. You take two objects, connect them, it just connects both. Like if you move one, other one will move, rotate, the other one will rotate, and scale, the other one will scale. Constraints are little complex compared to parenting, wherein you have a flexibility of connecting only move to move or rotate to rotate or scale to scale. And if you go to connectionators, this is even more complex connections, wherein when I say complexity, it's not the technical complexity, it is the way we connect them. The kind of connection that we can give is complex. The way we use them is actually very simple. When we go to the connection editors, so connection editor is something like you can connect, translate to rotate, or rotate to scale, or scale to something else. You can do a cross connection between anything you want. And I go with set driven key whenever I want to do something like limitations, like I want this to object to move only from here to here, not beyond that. Then I go with set driven keys. And if something which is even more complex and I want to do something, then I might look into something called as scripting or expressions, but that will be the last thing that I generally do. But this is the list of the connections that I generally follow. This is like a checklist for me. I already always follow whenever I want to connect anything. So if you master this, you can be a rigger, as simple as that. Yeah. So taking this, like using this theory knowledge what we saw till now, so I'll be taking very uh, like a simple session on how to rig a character. So I'll be showing you different methods or different things. I'm not going to rig the whole character, but I'll show you how you can do some of it, right? So let me jump to Maya. So I think you can see the screen, right? All of you can see the screen.
Yes,
So yes,
yes,
thanks.
it was
Yeah,
good.
yeah. So we have a character, a very like a kind of sculpted character, but doesn't have too much of details. And there is no facial details and all, because we are not dealing with the facial as such right now. So if you have to create joints for this, as I said, there are two different approaches that you can do. One is straight ahead. You can go with a very simple character rig with the basic bones. If the animation doesn't require too much of complexity, if it is simple walk or simple like basic loops that you want to create for games, right? If it is more complex, then you can go with a kind of different kinds of setups, like maybe different types of stretchy setups. All those things also can be incorporated into it, right? Let me just yeah. So I'll start with a basic join setup first for this. Right. So here, skeleton, create joins. So yeah, so if you have to create joints for this, so I'm going with as simple as possible, like simple joints. So I'll start with the pelvis region. The joints is too much. So some 3 to 4 joints is ideal that you can put for this, for a spine, simple flexible spine setup that you can create. And then after this, I want to create a neck and then a head somewhere here, right? So, and then skeleton joints. And there are some important things that you need to keep in mind when you're rigging, because if you're creating a model, most of the times if you're creating one single character or shape, you will end up with having 3 to 4 nodes in the scene. But when you're creating something like a rig, we will have multiple nodes in the end. Like there will be sometimes 100, 200, 300, or even 1000 nodes that will be creating in the end. So in that case, if you don't rename them properly, or if you don't keep all the objects in the scene clean from the beginning, it will be very difficult for you to even know what you're doing. And in the end, when you want to copy this from here to game engine, and you want to do something like uh, maybe retargeting the animation from one to the other, so all those things, it will be difficult if you don't rename it, right? So always make sure you rename everything properly. And the naming convention can be anything, but you have to follow one single naming convention throughout. um, okay, so here, coming to this, so I can move this friend. Yeah, move. I just want to keep it. So here, there are other ways of creating joints than this. Like in the newer versions, we have something like projected center and all, which also are very good tools for doing this. But I'm just doing it using the basic method of changing this using the joint orient, just placing them in place like this, right? Somewhere here. And it doesn't matter. See, there is something like reverse foot method. There is something like grouping method. So it's up to you whichever method you use. There is no problem at all. And yeah, this, and then skeleton, create joints. So we have this here. I'm starting with the clavicle, the shoulder. So before that, I just want to place it exactly. So here, shoulder. I hope most of you know how to use this tool. So I'm not explaining each and every tool that we need for this. So we can create even fingers for this, individual fingers for this. Right, I'm just creating. If at all you want to create individual fingers, yes, there are techniques again. Like if you're creating it manually like this, then definitely you need to depend on like manual way of doing. Like you can see this, there is an issue here. So when I try to do it like this, it's not aligning properly. The length is not aligned properly. So there is, you can use a workaround for this. I generally use locators, sorry, clusters for doing this. So when I go to edge, maybe, yeah. So maybe somewhere here I want the joint to be. I'll convert this to vertices and deform, create a cluster. So when I create a cluster, it exactly gives me the center position of that particular mesh, right? So same here. Somewhere here. Yes, exactly. So converting it to vertex, deform, cluster. There is even more easy method of doing that. I'll show even that, not for manual way of creating, for creating a game rigs, you can use that. So one more cluster. And then for each finger, you can have your own cluster there, wherever you want the joint to be placed, and then you can start creating. But right now, I'll just create one single joint for this, instead complicating this. So here, deform, cluster, right? So we have this. So you can connect all this. So let me switch off polygons, skeleton, joints. So holding a point snap, I'll just snap this. So this way you have all the joints in place without even rotating them. You don't have to go with the joint orient or anything as such. Directly it will connect here. And then I'll just select this, parent it to this. I don't need the clusters anymore, so I can delete the clusters. So all this can be deleted. So once this, maybe the basic things, like if you see the skeleton setup, there is nothing much beyond this for a basic rig. Like we have a torso, a head, hand and leg. So once you do on one side, you just have to take a copy onto the other side and then just finish it. So yeah, something like this. And then I'll start connecting this. So for connecting this, you need an extra joint just to change the connections from the left to right. So I'll go to skeleton, create joints, holding V, snap a joint here. Just move it down somewhere here. You can even keep it in the same place, no issues. And then parent this and parent this. So now you can see it created a connection. And this is important. Whenever you are creating a rig which is going to the game engines, always keep everything in a one single hierarchy. Like if you see now, there are two different joint hierarchies which are happening. One is this one, this overall thing, what we are seeing is separate and the hand is separate. That's okay. We'll just parent it now. Once we parent this here, so now you can see there is only one single joint setup for all these things which is happening. And if I didn't rename it, you can see how it looks. It's very complex for us to even understand what is what. Just by seeing this, we don't understand whether it is hand or joint, whatever, right? So that is the next, which is very important, renaming each and everything, and then correcting the local rotation axis and keep it clean. So for this, mm, so this is thigh. So I generally follow this thigh underscore left JNT like this. So let me just left JNT. Okay, so just will rename each and everything like this. I'm not going through all these things, but this step is something which is very important. And yeah, once all the renaming is done, and it should be consistent throughout. Like if you see, I'm putting a suffix of JNT in the end, so that says like that's a joint. And if it is a geometry, I'll put GEO. If it is a maybe IK handle, I'll put IKH, depending on what kind of object, because rigging will create multiple. There are hundreds of nodes that will be created, and it'll be confusing if you don't have the naming proper. So, and one more thing is, it is easy for us to select later. Like in Windows, we have this selection star dot whatever object you want. You can do that easily if you have the naming conventions proper. Right. And once this is here, I want to check the local rotation axis of this. So display, let me select hierarchy. Select hierarchy, display, transform, LRA. So we get this local rotation axis, and it's not that clean. We need to correct this. So I generally go with XYZ. So I'll go to orient. So X, Y, and X and apply. So now you can see it's little consistent wherein all Y's are one side and all X's are pointing down. So same with this, apply. Right. In this case, the character is actually not in that T pose. The hands are a little bit down, but generally we have a character in a T pose wherein the hands are straight, which is again very important for us. So rigging will be easy. The skinnings and all will be easy to do. Right, so just keep it like this, and it's more or less okay. So I'll just leave it as is. I'm not changing. I'm not bothered right now about the end joint, but even that can be corrected using some plugins or scripts that we have. So right now I don't bother about it. Right, click, select hierarchy, and display, transform, LRA. So now we got this. So now we just have to take a copy onto the other side. So skeleton, mirror. So YZ, I'll just keep it at behavior and apply. So we got the character setup, the bone setup done for this, right? So once the bone setup is done for this, it's a matter of giving skin for this. See, check the deformations, and if the deformations and all are okay, then you go with the control creation. Because once all the control creation is done, then if you check the deformers and if there is a mistake, it's very difficult for you to again come back and then look into that corrections and all. So it's always better we do it from the beginning itself, doing all this. So we have the character here. So show polygons, selecting this and this skin, bind skin. So when you do this bind skin, so it binds, and there are different methods in binding. So if you see the skin bind skin options, uh, there's a newer thing called as geodesic voxel, which is really good for skinning. So I'm going with geodesic voxel. So the skinning will be little clean and easy, so that you can edit faster after this, right? And after this is all about correcting the deformations by skinning. Like right now, I think it already has the proper deformation that we want. So we have this. So if it's like this, start rotating, I think it's decent for this. You can do all this, but we don't have any control as such for this. That's what uh, we can do on this. Like for maybe if I'm doing a leg rig, right? So I prefer going with a grouping method. So for that, I'll just show you how I'll do it quickly. I'll just show you how it is done. So show polygons. I go with um, IK handles, where RP solver reset. Yeah. So I go with this. So skeleton IK, and if it is difficult for you to see what is happening here, this, yeah, so it's something like this. So I created just 3 IK handles. So using these 3 IK handles, I'll create a rig which is used for moving the overall character. So if you see the polygons, I do this. So second, yeah. So I think you can see the character better now, but the deformations are still bad. So we have to correct all those things by skinning, painting the skins, which again will take a bit time for doing each and everything. But once we clear all those things, it will be clean. You can see now the deformations are not that great here. That can be corrected using paint skins. But yeah, so using these 3 IK handles, I'll create multiple groups to create what kind of animation I want. So just to show you how it works, polygons. Let's start with this. I'm not renaming everything right now. I'll just right. It's just, you can see there was a small issue with that. There was a cyclic error or something that I just did an undo. Here to here, yeah. So Control G, move it here. I'm just giving an overview of how this works. I'm not going to, I'm not explaining each and every step that I'm going to do. I just want to show you how this overall thing works. So Control G. One more here. So now in the end, if you see, we end up with 5 different groups and each has its own functionality of doing, like if we take this group. So let me go to polygons. Now, if you see, so this has its own function of the toe, and this has the toe rotation, and this has the heel rotation, maybe this way or this way, what we have. And then we have this overall toe, and then overall foot that can be used for moving this. So we have all these things, and all these things should be connected to a control which can be used for animation. So something as simple as this. So circle. Right. So leg control like this, a very basic control. Freeze. Show polygons. Yeah. So now this control, if I have to connect to this, so I'll take the final group what we have, just parent under this. This is what I was telling, like a direct parent will do this. So now we have that control to do all these things. And on top of it, we can create multiple attributes to connect uh, uh, all these attributes. We can do that, right? So maybe different animations, different rotations, what you want, we can connect all those things by using multiple attributes. That depends again on the pipeline, or depends on the animator, whether he wants it to be attribute based, or he wants it to be on the screen where the character itself have multiple controls to animate it. It all depends on the workflow or the pipeline that you're following. It's all preference, right? Because this is very important for us. In the end, when we are exporting this overall, like after animating this, like you create something like maybe um, a loop of walk cycle or maybe jump or something, and you want to export it to game engine. So we literally don't export each and everything from here, like the ike handles what we created, the controls what we created. We don't do that. I think most of you know that. We export only the mesh, the skeleton setup, and then the animation separately. So for doing that, taking the animation separately and then baking, sending it to a game engine, we do something called as baking. So if you see here what happened, um, let me just go back to this. Yeah. So there's some questions coming in. I'll look into that in the end. So skip it here. So when I go back to, yeah, the baking of it, like if I have to animate this, I just lift the leg up, selecting the control, set key, and go to somewhere around maybe 25 or something. Pull this up, set key. So now when you scrub the timeline, we have this animation. But whatever we are doing, the kind of animation that we created is actually on the control itself, which we are not going to export it to game engine. So this is what is important for us. In the end, we have to bake all this animation, which will convert all that ik animation to fk animation. Like I'll select all these joints. I go to modify, sorry, edit keys. I'll do a bake simulation. Selected all keyable. Let me keep as is applying. So it calculates. Yeah. So now if you can see here what happened. So all that animation that we created is now baked into the joint. So this is the data which we need when you're actually taking it to a game engine. So that's where when you're exporting characters, either using a game exporter from here, like even if you do file game exporter, or if you do send to Unreal or anything as such, it'll export into the form of an FBX format. So if you go to the FBX format that we have, so inside the FBX format under animation, so we have a direct option here itself for doing the bake animation. Like when you enable this, it automatically bakes it and then sends the animation to the game engine, right? Even though if you don't do it manually, it'll automatically do it. But I prefer doing it manually, cross-checking the whole thing and then exporting it. And even using this tool is also very important, like game exporter, wherein if you have multiple loops, like maybe you have a 20 frames of jump, and after that from 20th frame to maybe 40th frame, maybe you have kind of walk or something like that if you have. So all those things can be exported as individual clips separately if you are using a game exporter, and you can add multiple clips here. You can add one and define the frame numbers here, maybe from 1 to 100 or 1 to 20, like that, and then keep moving with that, right? But this process is like more of a manual method that we are doing, because it depends on the character. So this character maybe is a humanoid character, so for this we don't have to do this much manual work. We have tools inside Maya itself, or maybe other plugins that you can use, which will make your work even more faster, right? Even that can be done. But you have a doubt, like then what is the use of, if you have all those automatic things that can be used, then what is the use of doing a manual method like this? Yes, it is important if you are doing something like a characters which are not of real life, like which are more having some kinds of extra appendages, maybe different other things coming in place. So some extra dynamic animation you want to do, or some special controls that you want. So all those things are not possible if you are using automatic methods. So further, definitely you need to add manual. So you can do even one more thing, like you can do half automatic, and on top of it you can add some manual controls also. You can even do that. But if at all you are preferring to go with um, automatic stuff, like automatic, we have built-in thing that we can use inside. I think most of you used it. If not, I'll just show you how it works. It's really nice. um, okay, let me open the same file again. You see, don't save. Yeah, go with right import. Right, so this character. uh, so for this, so we have a built-in thing here under rigging, skeleton, quick rig, or human IK. So quick rig is a kind of human IK which we can use. Like if I go to quick rig, so it automatically calculates the overall. It's hiding here. Yeah. So we have two kinds of things. One is one click and step by step. If you do one click, it automatically calculates everything and then just creates rig. But sometimes there will be issues. So it's always better to go with step by step. So I'll go with step by step. So I'll add this geometry here. Yeah, that's the mesh that I'm going to use. And whether it's a perfect mesh or an imperfect mesh, that can be defined by whether you have holes in the mesh. Like if you have maybe the eye sockets or mouth socket, then you have to go with imperfect. But right now it's not there, but still I just keep it as imperfect and create and update. So it creates guides. Yeah, you can see now it created guides for us. And the guides what we got automatic are not that great. You can see the wrist guides and all are not that great. So these things can be moved and then placed however you want. But again, there are some limitations for this tool wherein we don't have options for creating all finger controls and all. If it is a basic rig for games or something, you can directly use this. I'll just keep it somewhere here. This for the neck, this for the head, it's all clean. This is for the knee and for the foot and for the base of the foot. Like this. And just, I did it on one side. I want to copy that onto the other side. So I'll just select the joints. They're not joints as such. They are guides. So show switch of polygons and then take this. So whichever I manipulated, I'm just doing this. So once this is done, so now you can go here. I want, yeah, skeleton and control rig. So I'm just creating a rig out of this. So once the rig is created, so it comes with all the controls, everything in place. So it's still, yeah. So now we got the controls in place. And right now it's not skinned as such. Like you can see, it's just the rig what we got. And this is very, like, it's a full body IK rig, which means like you have all kinds of systems. Like let me connect it to the mesh by clicking on, you can see it's like GVB, geodesic voxel, and then create or update. So it connects the joint setup what we created onto the skin or the model. So once this is here, so now you can use this to animate. And this has more flexibility also, wherein now if I select this and start moving, you can see the character moves along with it, right? And this rig can be used for even like retargeting. You, if you have some other animation things that are done, clips, you can retarget that animation onto this, and you can straight away export this into your game engine uh, very easily. Like you want to take this, the rig will directly go into game engine without any errors. You can directly use it just by going into file, export to Unreal, send to Unreal, or you can straight away export it to FBX and then directly open. It works directly. I'm not going to explain about the process of exporting the animation separate and this, I mean, into Unreal. But if you have to export those two separately, it's like this. Select the mesh and then the rig. We have the rig guides are not needed. The rig is something what we need. Yes, so select this and then this. So with everything selected, you just have to go to File, Export Selection. So when you're doing this export, the initial export, you make sure switch off the animation. So animation should be off. That means only the geometry and the rig is what we are going to take from here. And the next is the animation. So when you're exporting the animation, we again do the same FBX export, but that time we select only the joints, not the mesh, and then enable animation and bake animation and then do it. If at all you bake it manually, you don't have to do this. Right? So that exports the animation separately, which you can use to connect later in the Unreal or Unity or any other game engine that you're using. So that's the process that generally we follow, using two different um, animation and rigs separate and then taking it there. Right. Yeah, so this is definitely a very good tool for doing this, for creating a very basic, like if you are creating something like maybe your own small game or something, definitely you can depend on this process because it's very nice, user friendly, intuitive, very easy to create for basic animations and all you can do with this. Right. You can use this. All kinds of animations can be done on this. I don't know whether you guys know about the software called Mixamo. Even Mixamo you can use for uh, creating some kinds of, like, you can take your character, put it there, and then you can do it. Like, just show you. We'll just do a quick uh, understanding of how it works. Let me just open that. It's an online tool. Mixamo, yeah. So these are just different possibilities I just want to show you, so you'll understand how each one works. Like, there is a library of different actions that you can directly take from here and then apply. And you can import your own character also. Like if you see there is something like upload character. Like stop. Yeah. Open. So we have and definitely we have, it's like good for poses also, and you can even use this for creating simple loops which are already there. Like if you like something from this, you can directly use it. But the process of taking from Mixamo to Unreal or any other game engine, from Unreal it is okay because there is a straightforward option. For Unity, for Unreal you need to take and do some corrections if you're doing it. Right, like there is an auto rigger, just like next, and you can see here there are some markers, same like how we did with this. Like you just have to place them where you want the controls to be, and it automatically does the work for you. And one here and next. So it calculates, it does the calculation for you, and then it creates a rig, auto rig, where you can use all these animations onto your character. So it's calculating. It says it will take 2 minutes, but sometimes it'll be faster and even slower depending on the model that you're using. Yes. Yes, now you can see that character is uploaded with a basic rig, and next. Right, and you can make him dance, do whatever. So yeah, so you can directly use all these animations, put it on top of it, and then you can do this. You can see this, right? But this is like a different case, a different scenario. If you want to use something which is already there, and then like you want to finish the things, then you can go with this. But most of the times we do things manually. To some extent we use plugins which can be exported, do it, and then uh, do the overall process. It is only in an exceptional case that you can go with these kind of tools, and you can download this and you can use it, you can render it, you can take it to game engine, whatever you want from here, right? Yeah. So as I said from the beginning, like this, I just want to give you an overview of how this overall pipeline looks like and how rigging will play an important role for this games and animations. So I hope this gave you an overview of how it is, right? So with this, I'll just stop this demo session, and we can go with the question and answers. I think we already have some questions here. Let me go through them one by one quickly. Uh, yeah, I have to put the slide. So Q&A. Nice.
Yes, it's been a wonderful session. And today, being the World Youth Skills Day, and we are learning a skill like this, like rigging. And the best part, as a viewer, what I liked is when your character was dancing at the end.
Okay.
So, from a mesh to adding bones to making them dance, it's really incredible. So, yeah, like you said, we have many questions. So,
Yes.
maybe we can start with few questions here.
Yes. Yes. Yes.
Hope you
So
have been noticing all the questions and answering them.
I'm answering in between some of them which are related to what I'm doing, but yeah, let me go through one by one and then see if there is something same. I'll just skip it, but most of the things I'll try to answer. Yeah, and yeah, let me
Yeah.
see.
So, Ram Bhupati
Uh,
Kashinathan was
yes,
asking what software is being used, and
yeah, I
I
think
have.
that's already an answer. Like right now I'm using software is used for rigging. See, software doesn't matter not much. You can do it in Max or Maya or Blender or anything for that matter. You can use auto rigs like this. That doesn't matter as such. It depends on the final output that you want and the overall pipeline. That talks about what software you want to use, right?
Okay.
Never
Yeah,
software is
lot
important.
of lot of questions are related to software only.
Yeah.
They're saying is it 3D Max, Maya, and
Yes.
I also
Same.
have one question that Maya or 3D Max, which software is mostly used in gaming industry and why?
See, it's again not like whether it is a Max or Maya or something. Now it's like both. Previously, it was like most of them are using Max that time, and Maya is mostly into film. But nowadays, with the tools and all what we have in both the softwares, it is we cannot differentiate both. There are some studios which are totally depending on Maya, and some studios which are doing it in Max. You can do in both. There is nothing as you have to use only Max or Maya.
So there is that like is there any preference also, like when we talk about gaming industry, do they prefer some uh,
Software.
software over the other, or
No,
they
no, no, no,
do?
no, not really. That's what I was trying to say. Like, not really as such. You can use anything, any tool you want. It's like it should be same throughout the pipeline. What we are doing, like maybe if they prefer Maya, maybe they'll continue with the Maya throughout, or if they prefer Max, you can use Max. There is no constraint that you need to use only this software for gaming or this software only for film as such. Not like that.
Okay.
Yeah.
Pranshu Goyal is asking, do these things like Quick Rig or Maximo affect the jobs of a rigger?
No way, no way at all. See, in that case, if you, there are so many tools which will create a model directly, you can just scan it and then get the model done. Or you have things for creating textures really fast, unwrapping really fast, or this rigs really fast. So all these things are like helpers for us, which will make your work a little faster. Uh, they definitely don't are not a threat for the artist out there who is creating. They'll definitely be an add-on for you in the work to help you out, right?
Okay, great.
Yeah. See, initially, yeah, like just to answer this, initially we used to write things on a paper. Now we get something like scribbling on a pads or scribbling on a notepad or something. So that doesn't affect you creating. It'll just make your work a little more faster and it'll help you out. That's it, right?
Okay, great. So what exactly is baking? It's a question by Faizan Rizvi.
So baking has different answers related to rigging. Like if you yeah, if you're talking about baking in rigging or something, or animation, so whatever animation we do using IK setup or something, right? Or maybe if you're using dynamics, all that animation will be on the keyframes, like maybe on the starting frame and the ending frame, like that. But when you're exporting all these things to a game engine, we need keyframes on each and every frame. So when we are baking, so it literally translate the animation that we created into individual frames, like each frames, like if it is 24 frames animation or something, so it creates each key for each of the frame, which is like which can be used by the game engines.
Okay. Sachin with a smiley saying, for quadruped rig or any creature have so many hands and eyes, we also make a manual bones and controllers, or is
Yes,
it
that's what I was telling you, and this answers the previous question, wherein all these kinds of separate tools and plugins what we are creating, are they create, will they create any problem? So this is the answer. Like there will be some special things like this. Maybe you need to create some uh, things like maybe special creatures which has some extra appendages, maybe some wings or some kinds of things which are there. So all those things for you to create, definitely you need to go with the manual method of doing and manual control creation. All right, not all the plugins will help you out in rigging those kind of things. Definitely manual is important.
okay.
Yeah.
Why don't we use heat map or something other while skinning?
That's what I did. Like heat map is one technique of creating this. What I was showing you is geodesic voxel. Even that is better than this, right? I mean, each one has its own preferences, but I prefer geodesic voxel. Before geodesic voxel, yes, I used to go with heat map. But heat map, the problem with heat map is sometimes it creates an issue when you're working with a broken hierarchy, like the joints hierarchies are not connected to each other. Sometimes it might create an issue. So that's where sometimes I go with the basic skin setup also, a legacy method also I go with, right? But in all this, compared to that, geodesic voxel is good. That's why I'm going with geodesic voxel.
Okay, okay. Um, Ram Bhupati
Yes.
Kashinathan again is saying, is rigging good in Blender?
That's what we cannot compare tools. Definitely rigging is good in
No.
Blender too, and it is free software. You can definitely use Blender also.
So I think even if you know multiple softwares, that's an added advantage. And so if some people can even learn multiple tools in just in
uh
instead of just
See,
sticking to one, right?
yes, see, to answer this, like it don't be tool specific at all, because you maybe you join a company and that company might use Maya. And if you learn only Maya and do only rigging in Maya, and maybe you go to a different company, they use a different software, and if you don't know the software, that might be a problem. So it's always better, don't take software into consideration. Just understand the technique and how you can implement the same technique in different softwares, whether it could be Max or Maya or Blender or anything, right? That's why don't take software into consideration at all.
Okay.
Yeah.
So Ebenezer from Shasum is saying, great session, sir. Can
Thank
you
you.
please tell about the importance of storyboard for 3D modeling and animation?
Of course, it is important. Storyboard is definitely important for two things, like maybe not for modeling much, but for the animation, definitely yes, because that's what drives the overall thing. So if you have a proper storyboard, that defines where the character should be, how it has to be placed, how it has to move from where to where it has to move. So all those things is what is defined by the storyboard. So definitely it helps.
Okay. I have a very, I'll say a relevant question.
Hmm.
But again, it's related to software. What version of Maya or Max is used by industry nowadays? Abhi aajkal what's going on?
It's like we cannot say that. Like some studios they might still work on 2009 Maya 2009, or Maya sometimes Maya 2015, because they always have plugins already created for that, and they're used to that software, whatever, and that is working good for them. So it depends on the company. We cannot say like what software. There's some companies they use the latest version, maybe 2020. It depends. We cannot say that.
There were a couple of questions about the assets,
Okay.
3D game asset. I'll find that question. Before that, somebody has asked, they have not given their name. Can you do Ruby Cube rig?
We
Ruby.
Rubik's cube rig. Yes, definitely we can do a Rubik's cube rig, and I did a Rubik's cube rig, so I can relate it to that thing. And creating that Rubik's cube, I actually did it using procedural rigging method, because there it is difficult to create multiple groups manually. So I did a technique wherein I used mel script for automatically creating rigs, I mean creating groups whenever needed. It keeps shifting the groups, the objects inside the group automatically depending on which control you select. And the overall rig is done using uh, mel script. Like if I can see, okay, we'll just see if I can find it out. But yeah, we'll move on to the next question.
Sure. Pranshu Goyal, and there are a couple of more people who have been asking about the game asset. He's saying, what is the 3D animated game asset?
What is the 3D animated game
Game asset.
asset? Uh, See, it's like if you have an animation, see if there is a 3D asset, like in the modeling stage, we call it as 3D asset, a proper 3D asset or a character. So we have a model. And then if a texturing stage, yes, we also call it as an asset, which textured. And if it has some animation on top of it, like how I was explaining before, we take animation separately and rig separately. Even that is called as a game asset. Like each of this, which we use inside our game engine, these are called as assets. This question is, I think, character that is called as a 3D animated game assets. It's not compulsory. It should be a character. It could be a prop, or it could be anything that you can call it as a game asset.
Okay, okay. Got it. What is the difference between heat map and I
Uh,
think it's
yeah,
a
it's answered. Yeah.
yeah, that's answered. How to avoid or correct deformation? Is it always with the model or we need to do the adjustments with the rig?
There are things which has to be done in both modeling and then even in the rigging stage. So there will be situations wherein the model doesn't have proper line flow, the loops. So in that case, it will go back to modeling stage and then it will be corrected. And there will be situations wherein the model is good but the deformation painting is not that good, the paint weights are not good, then you have to do it in rigging stage itself. There will be some places where we use even corrective blend shapes. There will be something like post space deformers we use. Depending on which pose you are in, the deformation will be different. So all these kinds of plugins also can be used, but as I said, most of these plugins when you use, they will create their own nodes inside the rig, which might sometimes create problem when you're exporting it to game engine. So you should be aware of what game engine you're exporting and whether that supports this kind of plugin or not. But all those things are like, we cannot say that it's only in a rigging stage or it's in the modeling stage. It could be in both the stages.
All right. All right. What is the importance of poly counts in the model while rigging?
If you are doing it for film, not really, not at all. You can definitely use a high poly model and then animate if your system supports, render system supports. But if you're doing something for a game engine, definitely that is important. Depending on where you are going to put it, like what kind of game engine or final output. If it is going for a mobile, it's totally different. If it is going for Xbox or something, it is totally different. So each has its own specifications. If you're doing something for a mobile game, definitely you'll go with a very low poly character, right? So that's where all the other tools comes in, maybe the ZBrush, exporting maps and all comes in, but that's totally different. Yeah.
Although I have many questions, but they are more or less related to either software or comparing the software. But I see a very interesting question that I think everybody needs to know and that can motivate them as well.
Mhm.
Nowadays, we usually think that if a software is there, a human touch is not required, right? That's
Mhm.
what I've been listening. And a similar question is asked by an attendee here. He's saying
Mhm.
if we have these auto rigger softwares, then why would people want to hire a rigger?
That's where I was telling, like the similar answer I already gave, wherein it's not the tools, automatic tools, which will do most of the work. It will definitely help you to some extent, maybe 90% or 99%, but at least that 1% of work which is needed, definitely there should be a human thing. Like, because these softwares, how much ever we teach them, even with the machine learning or whatever we teach them, still there is this some kind of like maybe a human emotion or something which has to be added into it, which comes only if a human does that, right? Maybe there will be a stage in the some point wherein everything is done by that, but the modeling part, right? If we are doing a full body scan, we get a nice model, but again, we have to do a retopology on top of it. Same with this, you take the overall motion capture from the thread, but definitely not in the end.
That creativity and that mind will only come from the human touch.
Yes,
That
yes.
has to be there in all the fields. So whatever, uh, how technology can always be an added advantage, but yes, your personal creativity and your work is always appreciated.
Sure. Yeah.
With this, I'll say thank you so much for the lovely session, and being a non-technical person, I can say I have learned from this session as well.
Thank you. Thank you.
And, this is Unlocking Skills series going on, and I'd like to mention that we do have another workshop, that is day 3 of the workshop that is going on for product designing in 2D and 3D by Mr. Kalaikovin. Mr. Kalaikovin will be with us at 4 o'clock again today and tomorrow as well. And yes, this
Yeah.
workshop is also going to make you learn a lot. And like we were talking about the creativity and everything. So, yes, we have a Creative Me campaign going on. With this, you can add in your videos, your learnings, your work. You can whatever you have done or whatever your creativity says, you can showcase it and share on social media. Do tag us, Media and Entertainment Skills Council Vidyadaan, and a hashtag Creative Me. Participate in Creative Me competition, and you can get a chance to interact with our celebrity speakers and experts. And yes, being a world's youth skills day today, I would like to congratulate every skilled person. And with congratulations, I'll say let's play some drum session that will come on Thursday, July 16th. That is tomorrow, 6 p.m. And we will have Toril Cove, Academy Award winning director and animator, coming your way with a moderator, none other than Mr. Kirat Kurana, who's himself an award winning director and storyteller, on July 18th. We have a lot of sessions coming up for you. And so today I'll quickly wrap it because I know you all have to finish some work and then you have to be back at 4 o'clock for the next session. So, with this, thank you so much, Mr. Nagendra, for this lovely session, giving us your time and sharing your knowledge with us. Thank you
Thank
so
you.
much.
Thank
Thank
you.
you, guys. Take care. See you in the evening.
Thank you all. Thank you all for being a good listeners. Thank you. Thank you, Pooja.
Thank you. Bye bye.
Bye bye. Yeah.